Thank you so much for joining our webinar this morning in the UK with Mohi Uddin, who's going to be focusing on mastering shape and space. If you have any questions, as always, please feel free to write them in the chat box. And as I always mention, the PowerPoint and the CPD certificate will be provided automatically by email as soon as the session ends. I will pass it over to Mohi now. Thank you.
Hi everyone, hopefully you can hear me and see me clearly. Welcome to this CPD session on shape and space. If you can hear me and see me properly, if you can just type in where you're from and that you can hear and see me okay, that would be really helpful so that we can get started as soon as possible. Like all of these sessions, webinars, one thing that I always request, and I think last few webinars that we've delivered with Macmillan has been actually superb, because the audience have not only listened to what we're saying, which would be really helpful, but also they've really taken part in the discussions. So during our session, I'll be asking certain questions, whether they're mathematical based, so it might be a maths question, or it might be pedagogy based, which is more about thinking about the way we teach, the art of teaching. Whichever questions I ask, it'd be great if you can have a think, which I'm sure you will, and then type in your thoughts or your answers on the actual chat box. So on my right hand side, I can see a chat box. I'm presuming that you also have the chat box on the right hand side, or there might be a button somewhere that says chat, and then you can hopefully see and hear me still, but also you are able to type in questions and answers. So everyone say good morning, which is great. Just want to make sure you can hear me. So if someone can just let me know that you can hear me fine and we can get started, that would be perfect. So welcome to this CPD session. Great that Macmillan Education can hear me. Anyone else that can hear me, that would be brilliant. Brilliant. So we've got at least one person that can hear me. So let's get started. We've got two now. Brilliant. Okay, let's get started then. So welcome to this session. This is all on shape and space. The main focus on today's session, because we've only got like 50 minutes plus 10-minute Q&A session. We've only got that time. So the focus is going to be mainly on the area and perimeter topics that we cover in school, as well as some discussions on shape and shapes, excuse me. And then we have a Q&A session at the end. So the first question I would like to ask you is this one. Let me know which year group you're teaching, and let me know what is the most challenging aspect of shape and space for your year group, and why? Why is it, do you feel, the most challenging aspect of teaching shape and space? So I'll let you think about that for 2 minutes and type in your answer. As you do that, I'm going to start reading a few of your messages and replying to them. Hi Sam, welcome to our session from Thailand. Brilliant. I don't think that I can remember we had anyone from Thailand in our last few sessions, so you might be the first, you might not be. Good morning from Abu Dhabi. Hi Renette. I was in Dubai. My last session actually that I delivered physically was in Dubai in February, where I was delivering in the Middle East maths conference. Hi from India, Vaishali. Hi there. I'm from Bekasi. Where's Bekasi? That would be really, my geography is terrible. Hopefully my maths is better. So let me know where Bekasi is. Hi from Cape Town. We had lots of people from Cape Town the other day, and Russia as well. We had one session, we had like 200 people from teachers from Russia, which is absolutely amazing, or around about 200 if I'm not mistaken. Right, so Indonesia as well. I think first time I've seen Indonesia. Kuwait, welcome. Asha from Kuwait, and Botswana. Wow, I don't think we've had anyone from Botswana before. So the message is going all the way around the world, even further now, which is brilliant. Okay, so let's have your thoughts on what you feel is a challenging topic in the shape and space unit. So we've got one person, Suma. Thank you. It says introducing 3D shapes, I'm presuming, right? Introducing 3D shapes or yeah, it must be 3D shapes, right? I'm Shaden from Jordan. Hi, Shaden. We delivered actually. Macmillan delivered our one of our major conferences in Jordan. It was absolutely phenomenal. We had. I was so impressed with the Jordanian teachers. Actually, they were so engaging, and at the end, they all ganged up on me. There's about 30, 40 of them, and they started asking me so many different questions, which was brilliant to have because it shows how passionate they were to improve pedagogy and teach in the most efficient way. So you've said that to make understand the difference between perimeter and area. Ah, okay, right. That's an interesting one actually, to see the difference between perimeter and area. I think that's worldwide. There's a percentage of children that kind of get mixed up with perimeter and area. To make grade 2 students understand why we call shapes 2D and 3D. Ah, okay, right. 2D figures using golden ratio. 2D figures using golden ratio, says Josephine, sorry. Shaden says, thank you, Mr. Murray. I hope we see you again here. I do also hope, because Jordan was a beautiful place. I didn't get a chance to go around, but as much as I wanted to, but it was a beautiful place to actually visit. Okay, so we've had a few answers to that question. And I can see why we've mentioned those elements. And so let's have a think about one question then. So here's a question that I would like you to think about and try out. In this question, you can see there are 1, 2, 3, 4, 5, 6, 7, 7 squares. And it says here, is it possible to remove a tile and still have the same area or perimeter? Okay, explain. Okay, so I'll let you have a go at that and see if it is possible at all to do that. Is it possible to remove one tile and still have the same area or perimeter? Okay, so I'll give you about 3 minutes to kind of have a think and try that out, because there's two aspects there, area and perimeter. So it's about 1.5 minutes each to think about, and see if you can get that. Where I'm from, Alina may be asking, can you write where you are from? Sorry. And if it's me, Alina, then I'm from London. So I'm in London at the moment in England. So yeah. It has to be one shape. Yes, Sam. It has to stay one shape. Is it possible? So Ash is saying we can't have the same area or perimeter if we remove one tile. Does anyone disagree with her or agree? Or we're not sure. Okay, Vaishali agrees. Agree with it. Okay, quite a few of us agree with it. Great. Give you another minute or minute and a half. So with area, I would agree, right? Because we've got 1, 2, 3, 4, 5, 6, and 7. We've got 7 tiles there. So if I remove any of these tiles, then I'll have 6 tiles. So the area is not going to be possible for us to actually remove a tile and keep the area the same. That's impossible. You're right. Well done, Josephine, right? And others. But what about the perimeter? Is that possible to keep the perimeter the same, even if I remove a tile? Is that possible? Fozia says yes, but others are saying no, they don't agree with Fozia. Okay, so does everyone disagree with Fozia? Fozia is being very brave. Okay, she's going against all her colleagues. So is she correct? Possible for perimeter, says Toto. So Toto is also agreeing with Fozia. Okay, it says possible can be, says Asha. Okay, so how is it possible? Which tile would you remove to make the perimeter stay the same, but not the area? So you're saying remove the 6th tile, Toto. So I'm guessing if we think about 6th tile, then is this the 6th tile here? Is this one the one that you mean? 5th or 6th tile? So okay. So now someone who's that Sam is saying the 5th one or the 6th one will do. Is this the 5th one, Sam? And the 6th one is the one that I highlighted before and circled before, or just put a circle in before. All right, great. So let's see, why is that correct? If we get rid of this shape, then we lose these 2 lengths for the perimeter. And so we lose those 2, but what do we gain? We gain 1, 2. So we lose 2 lengths and we gain 2 lengths there of the same value, same units. We don't know if they're centimeters or millimeters or whatever it is. So we lose and gain the same number of units for the perimeter, and therefore if I remove the 6th tile, as someone said, then I still have the same perimeter. And similarly, if I remove the 5th tile, then I lose 1, 2 sides, but I also gain 1, 2 sides as well. And so that also allows us to have the same perimeter, even though we've removed 1 tile. Now, typically, what we tend to do with area and perimeter is we use really simple examples to go through perimeter. And this example here might be something that we look at after looking at both area and perimeter. But we can use something similar for the perimeter on its own and just get rid of the word area. So we might ask a question to our children after looking at perimeter: is it possible to remove a tile and still have the same perimeter? Explain. And so what we're trying to do here is get our kids to just think outside of just adding the lengths together. Okay, trying to just work out the perimeter in a basic way, which we need to do at first. But then one way to really master perimeter and area is to have more problem solving types of questions, to see the difference between the area and perimeter, but also to be able to understand perimeter in a in a much better, more efficient way. And so here, more in depth, I should say, not efficient. So here is a question I want to ask you. What is perimeter? Okay, so who can explain to me what is perimeter? What's the most basic way to explain what a perimeter is? Fozia says same for if we remove the 3rd tile. You're right, Fozia. There was at least, or was it at most, 3 different ways, right? We could have had the same perimeter in the previous example. Boundary of a shape, says Fozia, for what is perimeter? Around a figure. Some of the length. So Vaishali is being a lot more detailed in her answer. It says some of the length of the boundary of a closed figure. Shardine says, I explained to my kids as if we were measuring the walls of the room, okay, or out of the room, right? Because there may be walls in a room within a room. There might be another wall within a room, right? So would it be in the room or out of the room? Sum of all the sides closed. 2D shape in 2D shape. Okay, perimeter is the distance around a two-dimensional shape. The length of the boundary of a 2D shape. That sounds great. The boundary of the figure. It is the distance surrounding a shape. So some of us are using quite technical words as well, right? So the boundary. Not a huge number of children in the years. So we look at in England, we look at perimeter aged around 7, 8. Okay, we start to look at perimeter age 7, 8, and then area around 8, 9 years old. Okay, excuse me. So not a huge number of children, even in England, are going to be able to understand the word boundary straight away. But so what we need to try to do is in England, we will try to restrict the language that we're using to basic language so that children can understand the concept. And that follows on from theories from Zoltan Dienes about trying to be informal as much as possible. And that includes our language that we use. And so when we are informal and we kind of explain to children what something means in an informal way, or showing children in an informal way, then it's much more effective because they get the concept. Once they get the concept, the next step is for us to introduce the formal language, and that way we can kind of get them to see what it means. So some of us saying that it's the length around a 2D shape, okay, the boundary, okay. So what about this kind of shape? Is it possible for us to work out the perimeter if we don't have all the lengths in a shape? Is that going to be possible? Or do we need to have every single length in the shape to work out the perimeter? So Foz is saying it's possible. So what I want you to do is, if you've got the answer, don't write the answer down yet, but tell us if it's possible or not. And then in a minute or two, I'll ask you to tell me how it's possible or why it's not possible. Okay. And so I'll give you 2 minutes, 2 minutes to kind of figure this one out. Can you calculate the area for this shape? Is that possible at all? Benita says perimeter is the area, length and breadth around whatever is being measured. Is the perimeter the area? That's going to be confusing, right? If we say the perimeter is the area, what's the area then? Okay, so if we use the word area whilst describing perimeter, that wouldn't be correct, or would it? Right? So we have to, it's a length that we know, but it's not the area. So have a think about this question. We've got a shape that hasn't given us all the lengths. So how can we work out the perimeter of this shape? Josephine says, because all of the sides were there. Are all the lengths given to you? Not given to you, are they? I can't see the lengths being given to you. Don't answer just yet, Josephine. Give it another a minute and a half so that everyone has a chance to try to work it out. Some of us are probably drawing this out on some paper and then trying to figure out whether it's possible to calculate the perimeter. So give another minute and a half. Length and breadth is given, says Chanchal. But okay, but it's not a rectangle, right? Length and breadth of the shape is given, but it's not a rectangle. So we were told in our previous slide that we have to work out the boundary of the shape. The length and breadth doesn't cover that here, does it? Or does it? We can take that as 24, take away 10, says Chanchal. It is hard because we don't have the measurements of the zigzag sides. Shadeen says it's hard because we don't have the lengths of the zigzag sides, the steps, right? Or inverted steps, upside down steps. That could be the case, right, Shadeen? Is Shadeen wrong? Okay. At least we need to know 2 lengths of the zigzag sides. Having said that, do you think that lengths are equal? Do you think that this length is equal to this length? Is that possible? Looking at the shape, it doesn't tell us, but if you just looked at the shape, it's not, right? So these lengths are probably not equal. Okay, so that's even makes it even more challenging, or does it? Right? So that's something else for us to think about. They don't look equal and they don't tell us, so we can't presume. Okay, good. Well done, Shadeen. Asha says nope. I'm not sure. Okay, so some of us have said it's possible. Okay, so those of us who've said it's possible, can you tell me what is your answer? What is the perimeter to this shape? So those of us have said, yes, it's definitely possible. We can work this out. We've got the information needed. Can you tell me? Can you write down in the text box what you have, what you think the perimeter is for this? So some of us are saying 84 centimeters. So some of us are saying perimeter is equal to 84 centimeters for this question. Is that right? Okay, so we've got at least 3 of us saying that. Okay, probably a few more that haven't answered this question. So let's see if you're right. Now, I think it was Shadeen that said that we don't have the lengths of the zigzag parts, and that's why we can't work out the perimeter of this shape. But some of us are saying that we can because we've got everything we need, and they're saying that the length, or the perimeter, the length around the shape, the perimeter is 84 centimeters. Let's see how they've got that. So if we think about it, we know that this is 18 centimeters, and we know that this length here is 24 centimeters. But what's tricky are these bits, right? We just don't know what they are. But if we do this, if we think about it in this way, this length here, if I decide to push this out and make it go here instead, so that's gone, and we've pushed it out to the side. Can you see what I'm doing here? And this length, if I push this out to the end, I'll have this length. And this length here, if I push this out here, I'll have this length. And so the sum of 1, 2, 3, 4 of these lengths is going to be can you see 18 centimeters? Does that make sense? Great, Benita. So we can say it's 18. So just like, those films where we've got those secret walls, we can push them, right? If we push these down here, we will get the length, which is from all of this forms 24 centimeters. And so actually the perimeter was possible to work out, even though we don't always have every single length of the shape. We can still work it out in some cases. Okay, so here, those who said 84 centimeters is a perimeter are perfectly correct. Well done. Those who weren't sure, that's fine, don't worry. But what we need to start thinking about is problem solving questions like this for students to understand the technique is that's right, Vaishali. For students to understand this, it might be challenging, but how do we overcome that? Because they do need to know this type of question. They do need to understand that perimeter is not just from a rectangle and square. Actually, there's combinations sometimes of shapes that we have to put together, and some parts of the shape we might not straight away know the lengths. So how do we get around that? What we could do is use concrete materials. So in this day and age, right at this moment, what we have is we have a major problem, right? We've got children that are going to be at home, and we have to teach them from home. So one thing that we can do is allow them to have a bit more flexibility. So one thing that's way maybe to get a piece of paper, okay, a piece of paper, and cut a shape that looks like this. So or if you send it to them, if they've got printers, that's also fine. Right, this shape which is in front of us, can you cut the shape? Can you not hear me? Everyone, let me if you can't hear me. Dr. Rak is saying can't hear me. So if you just let me know that you can or can't hear me, that would be good. It's lagging. Oh, okay. Voice is lagging. Ooh, that's not a good sign. Hopefully the lag will disappear soon, because my broadband connection is pretty stable. Voice is breaking. It's okay now. Okay, it's okay now. Now you are audible. Okay, great. So what was I saying? So where was I? So I think in this day and age, well, not this day and age, but in this current situation, what we face is the prospect of our children, possibly for most of us, being at home. And so one thing that we can do is allow them to have a bit more of an investigational approach to learning. So in this, for perimeter, for example, I might just send them one question, right? I might just send them a question where it says, do this at home. Get a piece of paper and cut the paper so that it looks like the shape in front of us. And then I want you to write down the lengths that I've given you and see if you can work out how to work out the perimeter. So when children have something in front of them and they are playing around with it physically, it's going to allow them to explore more, like bend, fold, cut, push to the side if possible, right? See that more clearly when you've got it in front of us, right? And therefore, you're going to be able to do that now more if you couldn't do it in class. So, and that also allows your children not just to be sitting down all day on the front of a computer and just doing their work. So now we've got blended learning. So it's that combination of this interaction we're having through online. But how do I get them now to use approaches that I would love to use in class at home? And this is something that you can do more easily. So the question comes back, what is perimeter? It's adding all the, the sum of all the lengths around a 2D shape, but sometimes you don't need to know all of the lengths and it's still possible to work out the perimeter. What about this question? I'll give you some time to kind of work this one out. If I decided to add one more tile, what happens to the perimeter? So what happens to the area and perimeter? Okay. If I decide to add one more tile, what happens to the area and perimeter? Have a go at thinking about that. Give you 2-3 minutes for that one, and let's see what you come up with. So Fozia says area changes, perimeter may remain the same. So can you elaborate on that? When you say change, what does that mean? So area will change, but perimeter will be the same. So area will change. What does it change to? Does it change? Does it go up? Does it go down? And what about the perimeter? Does that increase or decrease? Because you said it may change, or so that are you saying that it can be increased or decreased or stay the same? Is that possible? Can it decrease? If I add a tile, can something decrease? Is that even possible? Area must increase in number, says Josephine. Alfana says area will increase. Area will increase as we add a tile. Okay. So imagine, so as you're doing this, those of us who are quite confident with the answer, and you don't need to think, you're not thinking about it anymore. What I also want you to think about is the pedagogy. Okay. In your country that you're in at the moment, the situation you're in. So some countries, they know for the rest of the academic year, we're going to be online already. And some of us might be going back online now, or some of us have been told it's online until we tell you otherwise. Okay. And so something you have to think about is the pedagogy, the style of the art of teaching online or through blended learning. And so can you imagine yourself asking these types of questions in a blended learning environment? So have a think about that as well. Free last down to remain same. Area increases may decrease, stay same, or increase, Shadeen. Perimeter remains the same, says Asha. It is lagging, sir. Oh, I'm so sorry it's lagging. We haven't had lagging issues on this platform much or at all, actually. So I'm not sure why it's lagging. Hopefully the recording will be good. I'm just going to check that my broadband speed is up to scratch. It should be, because we're in a quite good area for broadband here. That's good now. Okay, it's fine. Just lagging a little bit. Okay, great. Okay, so let's get back to this question. So we've had about 2-3 minutes now for this question. Hopefully it made some sense to you. So if we decide to add one more tile, what happens to the area? And all of you are right. Wherever I add the tile to this shape, it will increase. It will only increase the area by 1 unit because I'm adding one more. But the perimeter doesn't. It can happen. So if I add a shape here, if I add a tile there, excuse my my square, this is I can do, I think. If I add my square there, that means I've got one more unit for the area, but I've lost one side for the perimeter. But I've gained 1, 2, 3 sides. So my perimeter would be increased by 2. Is that right? And if I put a square there, then I would lose 2 lengths for my perimeter, but then I would gain 2 lengths as well for my perimeter. So that means if I put that there, then I would gain 1 for the area, as we would do wherever we put the square. But in this case, the perimeter stays the same. Okay, perimeter equals the previous perimeter. In this one, perimeter goes up or increases by 2. Yeah. And is there, some of us have said that the perimeter can decrease. Are you sure that's possible? Is it possible for the perimeter to decrease? That doesn't sound right, does it? Can the perimeter decrease? Put it in the middle. Oh, you mean that space that's missing here? Oh, not missing, but there's one that seems like it's missing, right? So if we put one there, what happens here? Look at this. If we put a square there, we lose 3 sides, but we gain 1 side. So here, the perimeter decreases by 2. Does that make sense, class? So investigational questions like this really help children to explore and to figure out that perimeter and area are 2 different things. something can decrease in this case, right? Perimeter can decrease if I add another tile, but the area increases if I add another tile. And I think the way that we're at the moment, and even before that, what we'd encourage in Singapore math style of teaching, the Max Math series, it should be quite hands-on at first. Now, we have that difficulty where all the resources are probably at school, and there's only a limited amount of resources in people's homes, in children's homes. So how do we get around that? So we can use simple resources, right? We could use simple resources like something like this, something like paper, or even drawing out tiles, okay? And that will help you to use what we called the CPA approach. And the CPA approach is something that we discuss pretty much in every single one of our webinars and our face-to-face CPD sessions. Why? Because it's such a major part of the way the Singapore maths approach is, okay? Because from research, we know that the concrete pictorial abstract, or the CPA approach, means for us to use concrete materials to introduce ideas, introduce strategies. In turn, that leads to a better understanding for children, and that will allow them to understand the abstract a lot better. But before we get to abstract, we want to solidify their understanding with pictorial representations, and then we would go into the abstract. Okay, so moving on, I think we're running slightly out of time. So use 12 tiles to make different rectangles. I'll let you think about that for a minute. How many different rectangles can you make with 12 tiles? You don't have to use all of them, and sometimes you can use all of them. So the question is, how many different rectangles can you make with 12 tiles? I'll let you have a go with that. So the question is, how many different ones? Not which ones, but how many different ones? I'm just going to turn my radiator off. It's getting really warm in here. I don't know what time it is in where you are. Let us know what time it is, AM or PM as well. At the moment here, it's 8 AM. So we started our session, or it's 10 past 8 now, but we started our session at 7:30 in the morning in England. Okay, that's gone. Okay, the circular motion has gone. Okay. Okay, so we've got loads there. Okay, so I've picked out one or two. Okay, so here I've used my 12 tiles to make a rectangle. Okay, here the rectangle is a 2x6 rectangle. Class, how many rectangles have I used here? I've used 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Great, we counted, we've used all 12. Is there a faster way for us to count how many there are? I know that we've counted 6 at first, and there's 2 rows here, so I could also do 6 times 12. That's great. That's another way of counting how many squares I've used, and it's a bit more efficient, right? What about here? Is there a way I can work out how many tiles I've used? I can see that there are 3 here without even counting. I can see that there are 4 here without counting, and therefore 3 times 4, I know 3 times 4, 3 lots of 4s or 4 lots of 3s is going to give me 12, and I know this is going to be 12 as well, right? 12 squares. We don't know if they're centimeters or millimeters at the moment, so this is for teachers, so we're not going to say millimeters or square. I'm asking how many of these squares have we used to make this rectangle, okay? And so here, I mentioned it a little bit earlier, sorry, that we try to introduce ideas and concepts, not only use a CPA approach, the concrete pictorial abstract approach, but also we try to do so in a way which is informal. Can you see how informal it is here? I'm not talking about centimeters or square centimeters or millimeters or square millimeters. I'm just asking a simple question of how many squares. This language that most of our children should be able to understand by this stage. How many squares do I need? How or have I used to make this rectangle? Okay, and that's something that's easy to do. But also at the same time, I'm getting them used to thinking about efficient ways to calculate how many by multiplying the length and the width, right? And so without telling them this is the general formula, one thing that we try to do as much as possible is for us to avoid telling our children this is the general formula. We want them to be able to work that out themselves and tell us, because when they tell us, it's a lot more powerful. When we tell them, it sometimes goes in or goes out, right? Or both, right? And so when they work that out themselves, when they discover, it's like a discovery. You know, when you discover a new land or a new recipe, or you want to try something out, right? When you discover something tastes great, you want to have more of it. It's like that. So once you kind of get them used to having that feeling of discovery, it's a really powerful way for them to learn. And so here, what we're trying to do is use a CPA approach using the tiles, but at the same time, what we want that to lead to is me using this pictorial representation. Class, I've got this other rectangle. Now, this other rectangle is on this squared paper, so it's a bit easier for us. So we don't have to use square tiles all the time. We've got square paper, right? So it's a bit easier for us to work out how many squares there are within that rectangle. We've got the same one, right? Oh, look, we've got 4 and 3, and so this is 12 squares. Okay, but class, if I told you that each of these lengths is 1 centimeter, that means we have 12 centimeter squares. We've got 12 lots of centimeter squares. And so what we say is this is 12, and how we write that is 12 square centimeters, like this. This is the notation that we use. And what we've worked out in today's lesson by calculating how many squares are within a rectangle, we're working out something called area. Is actually look at. Hopefully, you can hear me. I've got a message that says my internet is gone, but I can see that my speed is absolutely fine. So hopefully you can still hear me. But as I'm saying, that firstly, what I want to do is I want to make sure that children understand the concept. How do I do that? I do that by looking at informal ways of understanding what area is. Before I even mention the word area, I want them to know what area is, but I don't want to say the word area. Okay, even in my title at school, I wouldn't have the word area there. Okay, I would want them to try to understand the concept first. Then I'm already getting them to think about the general rule for to work out the area of a rectangle. And that's when I can then introduce more concept, more formal concept of general formula. So I might have a go here. For this question, we've had a go. I might have another go here. How would I work this out? I know there's 6 here and 3 here. So that's 6 times 3 is 18 of those squares. Now, class, if I told you that I don't know the length here, okay, I don't know the width, how can I work out, what would I need to do to work out the area of this shape? I would need to multiply the length times the width. I want to hear that from them. Whatever the length is here and the width, to work out how many squares make this rectangle, I would need to multiply the length times width. And then the next step would be to have, not straight away, maybe not even in the same lesson, but to have a rectangle without the squares, right? Without the squares, and instead of having the squares within the rectangle, just a plain rectangle, telling them that this is 5 centimeters and this is 6 centimeters, is it possible to work out how many centimeter squares? How would I do that? Maybe we would draw some squares in and then realize, it's just 5 times 6, right? And that's the process we want them to go through. And so when it comes to lessons on shape and space, because there's quite a lot of technical aspects, it's really important we try to go through the CPA approach, the concrete pictorial abstract approach. But not only that, we also must try our best to go through an informal, formal practice approach. So starting off with informal language, informal processes, like we did with the area question, then moving on to formal learning, which is when we start to introduce key words and also general formulas. That's very formal, right? And then moving on to getting them to practice as well. So let me know if that made sense to you, or if you're not sure about that either. Okay, so I've got still a few more activities, but I don't think we can go through all of them in the time that we have left. Okay, so I'm going to go through one. I've got 3 left, so I'm going to go through one more, and that could be something like this one, I think. Okay, so let's go through this one. So well, actually, this might be a better one. Okay, so I'll go through one more activity. So have a look at this question. It's from our textbook, and then what we'll do is we'll start to wrap up our session and then have a Q&A session after this. I want to go through the TPK with you, and that's like our online teachers resources, and we'll have a quick discussion on that as well, and show you how important it is to have something like this for your own teaching, especially if you are in a blended learning situation, and how that can help you. So have a go at this. Here's a shape. Okay, it's a compound shape, and you've got the lengths, but you might not be able to see the lengths on your computer. So I want to write them down. This is 3 meters. This length here. This is 2 meters. This is 2 meters. F is 2 meters, and this is 1 meter. And we're not given E and D. Okay, so I want you to try to work out. It says find the area of this work desk. Okay, so have a go at that. But this is what I want you to do. I want you to work out the area in more than one way. So if you've got the area, great. Write that down somewhere on your paper. Okay, and then write down the method you use to work out the area. But then I want you to try to get at least 3 different ways of working out the area for this table. Okay, I'll give you 2 minutes to try to do that. So suppose this is area is 4 meters squared, or 4 square meters. Right. So okay. So there you go. So Shadeen's come up with a few different methods there. Got 3 times 1 plus 1 times 1. 1 that we split this up into 2 rectangles. Is that rectangle and a square? So we've got 3 times 1 which is 3 square meters. And this shape here, this must be 1, excuse me, times 1, which is 1 square meters. We know that's 1 because that's 2 meters, and that's 1 meter. So this length here must be another meter to make the 2 meters whole, right? So we've got 3 meters, square meters plus 1 square meter is 4 square meters. That's one way. What's the other way? Is there another way? Someone said maybe 2 different ways we can break this rectangle up, right? So maybe we can have a rectangle like this, okay? So we've got this rectangle and we've got this rectangle here. Okay, so we've got 2 by 1. Is that 1? That's 3 meters, that's 2 meters, that must be 1 meter here. So this is a 2 by 1, which is 2 square meters. And this here must be, if that's 1, that must be 2 square meters. That's 1. That's also 2 by 1. So that's 2 lots of 2 by 1s. And therefore, we've got 2 square meters here. Okay, so that's 4 square meters altogether again, right? And our third way, as a lot of us rightly pointed out, that we can actually have um, we can actually have something that looks like this. Okay, we can actually have a bigger rectangle like so. And so we've got a 2 meter by 3 meter rectangle. So 2 times 3 equals 6 square meters. But then we need to get rid of this area, which is not part of the shape, which is a 1 meter by 2 meters. Is that right? A 1 meter by 2 meter rectangle, which is going to be 1 times 2, which is going to be 2 square meters. We take that away and we're left with 4 square meters again. So why have I kind of made you think about this question? Well, it's because one of the things that we really strongly encourage is multiple strategies to get you to think about more than one way, or get your kids to think about more than one way of solving one problem. Because there are lots of different ways of solving questions, right? Especially in maths, most of the times for problem solving, there's probably a few ways, right? In most cases. So what we want our kids to do is think of more ways and give them more depth of understanding. Because if they think there's only one way, it's not the best kind of way to think. Because in life, in reality, when we have a problem, there's many different ways of solving that problem. And if we just think there's only one way and we get stuck in that one way, then we just don't think of any other way. So we want that flexibility. We want them to be able to encourage them to think outside of the box sometimes. And we want them to have multiple strategies, okay? And that's really important as well for that flexibility. There's a good saying. It says something like, it's better for your children to learn to solve one problem in 5 different ways than to solve 5 problems in just one way. Okay, it doesn't literally have to be 5, but it just means that it's better for your children to know many ways of solving one problem rather than focusing on solving 5 problems in just one way. Okay, so have a think about that. Okay, so we're going to kind of like start to wrap up our session now. And just want to go through some of the TPK examples. So we've got because of the situation we're in, it's quite challenging, right, to kind of teach your children whilst at the same time thinking about blended learning, because it's not your usual way of teaching like in class. And so that adaptation we're making is a big challenge. And so what Macmillan has done is create the resources and make the resources accessible to you so that you have a much smoother way of planning and limit planning time you spend, and also focus on things that you probably would have done in class, like for example using real life examples that's already in our textbooks, but also having a more traditional way of teaching online is also very important, right? So looking at our TPK, I'm going to share my screen with you share screen with you. Slightly slow. Okay, so hope you can see the screen now. And there's my speed test, just to see that we're doing well in speed. And so here, what we can see is that we have various different resources. We've got all our textbooks online, so that if you wanted to access any of the pages from our textbook, is there. Not only that, we've also made available our workbooks online as well. So all of the questions that your children will be doing in class are also online for you to be able to access and use, which is absolutely phenomenal, actually. On top of that, we've got so many other resources in our teachers resource pack, including CPD online professional development videos that you can go through in your own time or with your school. But also we've got assessment packs. So we had a webinar last week on assessment, and we went through the three assessment packs that we have, three different styles of assessments that we have. One is the initial assessment at the beginning of the year. One is unit assessment, so every 2, 3, 4 sometimes chapters. And one is the end of year assessments. And all of that is within the TPK, which is the online teachers resource. And so what we'd strongly encourage you to do is check out our TPK. So something went wrong there, so I'm going to go back a step. So check out our TPK, and you see how useful it is for you, especially in the time that we're in at the moment. So coming back to our presentation, just kind of finalizing. So don't forget the 3 or 5 core essentials of the Singapore Maths approach, which is 1, representation, then generalization, and encouraging number sense, and communication. Now, communication is going to be challenging for you. So depending on what interface you use for your lessons, especially if they're online now, communication is something that we need to probably work on a bit more. So some interfaces have rooms that children can go into, online rooms that they can go into in groups and have a chat about whatever question you've set them. And so that would be something that you probably would be using if you have that opportunity to do so. And metacognition, which means just thinking about thinking in the most basic term. We won't go through that now because we've gone through that in a lot of our previous webinars. Do check out our webinars and our social media sites. Thank you so much for attending this session. We've had a quite consistent 62 to 64 delegates watching, so which is absolutely fantastic. If you want to contact us after this session, feel free to do so through our social media sites. Make sure you follow all our social media sites, because there's lots of goodies and freebies and lots of information and sign-ups that I think you'll all benefit from. And I think it's really important that, you know, we try to encourage ourselves to go through CPD, because sometimes it can be challenging, but that's part of learning, right? So sometimes I might have asked you some challenging questions which you may or may not have understood, or you maybe even got wrong sometimes. But now you know how it sometimes feels for our children when we ask those same types of questions, right? And the reaction that they would get if they get it right or wrong. And so that's also a major part of CPD. It's nothing to be worried about at all. Is very much encouraged as well. So yeah, follow our social media links. There's our website there as well. And if you have any further questions after this session, you can also email international.curriculum@macmillaneducation.com. And now is a Q&A session. We've kind of like just about used a whole hour on the CPD, but I'm happy to stay back for another 5-10 minutes to answer any questions that you have. Hopefully this session made you think. And if it didn't, then something I'm doing wrong, but it should make you think. CPD sessions have to make you think, not just about maths, but also about pedagogy. And pedagogy is a huge part of teaching maths. So bear that in mind. Any questions? I'm open to your questions right now. So thank you so much for your lovely comments. You've been absolutely amazing too. So I'm looking forward to our next session, which is today at 10 o'clock, which goes to the same slides. So if you've been here today, then you don't have to attend another one. But do tell your colleagues if you felt that this was useful and they can make it. That would be great. I think you can still register. I'm not sure actually. But yeah, I'm sure you can. So any questions, that would be great. If not, you don't have to ask any questions. I don't see anyone typing, so I think that's probably it in terms of questions. But I can see Josephine typing just as I said that. So I'll give you another minute or two, and if there's no questions, then I'll hand it over to Raina, and she can take it from there. Thank you, Shadeen. Thank you, Aswati. Could we talk a little bit more about TPK? Yeah, sure. I can share my screen again, and hopefully I can take you through the TPK. But it says page not found, so I don't know if there's something wrong with the internet, but I've just checked my internet. It's like blazing fast speed, so I'm not sure what's going on there. So let me go back. So TPK is a teaching resource that we have that's purely online. So what you'll find is you have different books. So let me go back and I'll take you through it slowly. And that's presuming it will work. And so TPK is a whole array of resources, including here we go, that's better. So including our primary collection of books, so Max Maths series of books, we've got grade 1 all the way to grade 6, for example. You've got the digital student books that you'd have generally in class on their tables. You can go through them by clicking on view. You can go through every single page. You've got teacher presentation packs here, and you've got teaching resource center as well. The teacher, the books will look something like this. You can click on the book that you want to go through, and it goes through the books with you. The teaching resource pack includes things like the workbook, the videos. So some of these videos that we record in the webinars, they'll be in the teacher resource book. If I can click on that, teacher resource center, excuse me. Here, this is a teacher resource center. So you've got flashcards that you can print out. You've got scope and sequences of lessons. You've got unit sheets, worksheets. You've got teacher notes, so more helpful guides for you. You've got specific, technical words that you might struggle with your children. So we could have like worksheets and those printouts. You've got professional development videos. I'll see if we can go through those. We've got professional development videos there. We've got the workbook that you would use normally in class if you're there. If you are not in class, you can use that as part of the TPK so that your children can access the workbook from their homes. We've got journal printouts, and we've got assessment packs. So these are assessments you do. Formative assessments should be happening, in your lessons as much as possible. But these are summative assessments that you want your children to take probably at the beginning of the year, and also in the middle of the years. You probably have every 2, 3, 4 chapters, depending on how much you want to cover, and then you have a formative assessment, and then at the end of the year, the whole academic year, you have a summative assessment where it covers most of the topics that you've covered in the year. You can't cover all because there's too many, but most of the core ones you can. And you can see that these are videos. So you can see my name there, Mohi Uddin Ahmed. It's a Max Math Stage 6 video 1. So these are actually, some of these are webinar videos, which we've got here, but these are also videos explaining the TPK and other aspects, teachers' guides of the TPK and so forth. Not only that, but also giving you some real life examples of how to teach using the books that we have, the Max Math series. And so these are really useful for you to have, not just in the time that we're in now, but also when you get back. So even if your school is online now, and in 2-3 months time, you're back in school again, is a huge investment for you, not just for now, but it's for the future as well. So I think it's so much more helpful than just in school or just blended learning. It's a combination of both. And what I've been really impressed, though I don't work for Macmillan Education. I work with Macmillan Education. What I've been really impressed with Macmillan is that the ability that they have, because they're such a huge company. But when you're a huge company, there's a lot of paperwork and a lot of issues that come with that. Okay, it takes a bit longer to be flexible. But this situation that we're in, coronavirus has made us as teachers, we had to be flexible like that. Within a day, we're online, right? So we just had to deal with it. And the brilliant thing about Macmillan is that they're so good at being flexible that within a short period of time, we had the things like the workbooks online for you to use for your children at home. I mean, that is pretty much unheard of in publishing industry. So especially with a huge company like Macmillan. So that's something that I think is only works to your favor, because then if there are future changes because of coronavirus or anything else, you're going to be in a good position, because Macmillan, I'm sure, will look after you and your school. Hope that explained it, Josephine. Thank you, Unita, Gurjeet, and I'm not sure what that means actually. Autism. Oh, thank you so much. Okay, right. Tism, I get. Okay. Great. So I don't think there's any other questions. So I'm going to pass it over to Raina, and hopefully she can take over from there.
Perfect. Thank you so much, Mohi, as always, for your great content and also the engagement of the attendees. I'm glad you know what TYSM means now. It's good. It's good. Abbreviations. But as Mohi mentioned, in terms of the TPK, it is something that we're really pushing forward at the moment, particularly for blended learning. If you do want to know more about our resources, as Mohi mentioned, please do email us. And the PDF of the webinar and the certificate will automatically be available as soon as the webinar finishes. Do follow us on social media, and we look forward to seeing you very soon. Take care for now, and see you soon. Bye.